All right, folks, we have been working for the last week or so on factoring, and we have learned the three methods. So you know how to take out a greatest common factor, you know how to factor a difference of squares, and you know how to factor a trinomial using the guess and check method. Today what we're going to do is kind of a factoring summary. We're going to be putting it all together. Now, as we do this summary, what may happen is that in some problems you may have to use more than one of our factoring methods. So here's the way this is going to go. When you get a problem to factor today, first you are going to look for the greatest common factor. The problem may not have one, but we are at least going to consider that possibility. And if there is a greatest common factor, then we are going to remove it. Now, once you have removed the GCF, if it's possible to do so, then what you're going to do is you're going to look at your problem, and if there are two terms, and it fits that pattern of a squared minus b squared, then you are going to do the difference of two squares method. And you'll remember with that there were three questions we had to ask. Is it a binomial? Does it have subtraction? And then finally, are the terms perfect squares? Now, if the problem that you're factoring is three terms, then we learned how to factor things that looked like this: ax squared plus bx plus c. And we did that using our guess and check method. So every problem is going to start out by looking for a GCF. If there is one, we're going to move it. We're going to remove it. If there isn't, then we'll move on. And we'll look to see if what we're factoring has two terms or three terms. If it's two terms, is it the difference of squares? If it's three terms, is it ax squared plus bx plus c, so that we could try our guess and check method. So we're going to go through some examples here. And on all of these, the instructions are to factor. And remember that factor means to write it as a multiplication problem. All right, so here's the first problem we're going to look at. We're going to factor 18 m to the second n minus 2n to the third power. Now the first thing we're going to do is look at this to see if there is a possibility of removing a greatest common factor. That's how we're always going to start. So remember what we do. We look at our coefficients first. We have 18 and 2. And we try to find the biggest number that both of those will evenly divide by. 18 and 2, I know will both divide by 2. So 2 is going to be a part of my GCF. Now I turn my attention to the variables. Now remember, the first thing is that they all have to have it. And then the second thing is, if they all have it, then I take the smallest power. So I see m's and I see n's. Do all of the terms have m's? The answer is no. So that means I can't put m in my GCF. What about n? Do all of the terms have n's? They do. So I can take the smallest power of n, which is n to the first power. So my GCF is going to be 2n, and that will be the first part of my multiplication problem. So now remember, think about distributing. You have to multiply 2n times the first term and get 18m to the second n. Well, you would need 9m squared, so that when you multiply 2n times that 9m squared, you can get 18m to the second n. Now, 2n times your second term would have to give you a negative 2n to the third. So it looks like there we're going to need a negative 1n squared. A negative 1n squared, so that when we do 2n times negative 1n squared, we can get negative 2n to the third. All right, so we have successfully taken out our GCF. That step is done. All right, now here's what I need you to do. Now that you have removed your GCF, I need you looking at what remains inside the parentheses. Is it 2 terms or is it 3 terms? Well, it turns out that what we see inside the parentheses is 2 terms. So I need to check this to see if it is a difference of squares. If there's a possibility that I could factor that using that difference of squares method that I learned. So, is this a binomial? Yes, it has 2 terms. Does it contain subtraction? Yes. Are these 2 terms perfect squares? And the answer to that is yes, because 9m to the second is 3m times 3m. And n to the second is n times n. So what that means is I'm going to factor some more. Now, watch this. I'm going to take this GCF and I'm going to move it down. So I'm going to bring that down to the next line. Can't lose him. And then for 9m squared minus n squared, I'm going to put 2 sets of parentheses because I'm going to use my difference of squares method. All right, what can you multiply times itself to get 9m squared? You can do 3m times 3m. And then what can we multiply times itself to get n squared? That, of course, would be m times n. And we know in that difference of squares pattern that one of these is a plus and the other is a minus every single time. So now that I have done my difference of squares, here is my final answer. That is my final factored answer. Now I want you to notice it has my GCF in it that I took out, and then my difference of squares that I was able to factor after that. So you're using 2 of the methods. You're doing GCF first, remove this 2n, and then we're taking what remains inside the parentheses and applying that difference of squares method to that. So that's the way these are going to go today. Not all of them, but it's a possibility now that you may have to use 2 of the factoring methods to get your answer. All right, so let's look at another one. Let's do 2x squared plus 20x plus 50. Okay, so the first thing we'll do on this one is look to see if there is a GCF that we can remove. Coefficients are 2 and 20 and 50. All of those will divide by 2. The only variable I see in the problem is x, and all of the terms don't have x, so I can't put x in my GCF because they all don't have them in common. So it looks like on this one your GCF is just a 2. So that 2 will give you your start for your multiplication problem. So 2 times the first term has to give you 2x squared, so that needs to be an x squared. 2 times the second term has to give you positive 20x, so that should be a positive 10x. And then finally, 2 times the third and final term would have to give you a positive 50. So that would have to be a positive 25. So the GCF part of this is done. All right, so now what we'll do is we'll look at what we have inside the parentheses. And what I see there is 3 terms. So I at least need to try to guess and check that. All right, so let's give this a try. So notice, I'm going to start by bringing the 2 down to the next line. Don't lose your GCF. And then we're going to put our 2 sets of parentheses so we can guess and check. All right, so we'll start with x squared. What can we guess for x squared? Well, we know the only way to get that is an x times an x. All right, now I'm going to come out here to the other end, and I'm guessing for positive 25. So I know that's 1 times 25, and I know that's 5 times 5. Since this is 1x squared, I know that I can look at this and say, okay, the 5s seem most likely to get me that 10 in the middle. So I'm going to try a positive 5 here and a positive 5 here. So here is my guess. I think my multiplication problem needs to be 2 times x plus 5 times x plus 5. So now we're going to check this. Okay, so I've got my 2, and I'm going to do x times x, which is x squared, x times 5, which is 5x, 5 times x, which is 5x, and 5 times 5, which is 25. Combine my like terms will give me 2 times x squared plus 10x plus 25, and then I'll distribute my 2. So 2 times x squared is 2x squared, 2 times 10x is 20x, and 2 times 25 is 50, which is exactly what I wanted. So this would be my factored answer. Notice I have my 2, which was the GCF that I removed, and then the x plus 5s that I got from factoring my trinomial using guess and check. So this is a problem where we could do the GCF followed by guess and check for the trinomial. So again, notice it's not really that you're learning a new method here, not at all. What you're doing is using more than one method in the same problem. Okay, next up, let's do 30x to the third minus 27x squared plus 6x. So we'll start by seeing if there is a GCF that can be removed. All right, so when I look at this problem, my coefficients are 30 and 27 and 6. I think the biggest number that all of those will evenly divide by is a 3. All right, next up, we are going to look at the variables. All I see are x's, and they all have it. So that means I can take the smallest power of the variable, which is x to the first. So I have a GCF of 3x. All right, so start my multiplication problem off with that 3x. And let's see what's in the parentheses. I need 3x times the first term to give me 30x to the third. So I'm going to need 10x squared to make that happen. Then 3x times the second term needs to give me negative 27x squared. So that's going to be a negative 9x. And then finally, 3x times the last term has to give me 6x. So I'm going to need a plus 2 for that. So here I have my GCF, and here I have a trinomial. So inside those parentheses, I see 3 terms. So that means I should try to guess and check. All right, for my first term, 10x squared, I know I could do 10x times 1x, and I know I could do 5x times 2x. And then my last term is a positive 2, and I know the only way to get that is 1 times 2. Notice that I want a negative 9x in the middle, so that means I'm going to need negative numbers here, and I'll need 2 of them, because it would take a negative 1 times a negative 2 to get me a positive 2. So notice, this 3x is just sitting here waiting while we try guess and check on this trinomial. He is ax squared plus bx plus c. So I need to try that. All right, so here we go. I'm going to make my guess. I'm going to bring down my 3x. And I think with this combination, with the 10x squared, that I'll try the 5x and the 2x. And then over here, my negative 1 and negative 2, I think I'll try the negative 2 in here with the 5x and the negative 1 in here with the 2x. So this is my guess. Now I'm going to check. All right, I'm going to leave this 3x alone for the moment and just do this multiplying. So 5x times 2x would give me 10x squared. 5x times negative 1 would get me negative 5x. Negative 2 times 2x would get me negative 4x. And negative 2 times negative 1 would get me a positive 2. Bring down my 3x and let's combine like terms. And here we'll get 10x squared minus 9x plus 2. And then we'll distribute the 3x. So 3x times 10x squared is 30x to the third. 3x times negative 9x is negative 27x squared. And 3x times 2 is positive 6x. That is correct, which means that this is my answer. So again, notice on that one that we are using our GCF first, and then guess and check on the trinomial inside the parentheses. Okay, next up, let's try this one. 48w to the second minus 36w. We'll begin by looking for a GCF. All right, we have 48 and 36. Both of those I know are divisible by 12. Variables, all the terms have w's, so I can take the smallest power of w, which is w to the first. So it looks like I'm going to start with a GCF of 12w. Write my multiplication problem. 12w times the first term has to give me 48w squared, so I'll need a 4w to make that happen. And then 12w times the second term has to give me negative 36w, so that's going to need to be a negative 3. So GCF of 12w comes out. Here's what I'm left with. I want you to notice that is 2 terms. So we need to see if we could do difference of squares on that. Is it 2 terms? Is it a binomial? Yes. Does it have subtraction? Yes. Are both of these perfect squares? And the answer is no. For 4w, it's not w squared. So there's nothing I can multiply times itself to get 4w. There's also nothing I can multiply times itself to get 3. So what that means is I cannot do the difference of squares method on that. So I am done. So here's an example of a problem where all you have to do is GCF. And then you're not able to go on and do the second part of the problem. So that is an option. That is something that can happen. Okay. Let's factor 9m squared minus 1. All right, we're going to start by trying to identify a GCF. I have coefficients of 9 and 1. The only thing that both of those will divide by is 1. And then I see m's in my problem, but all the terms don't have it, so I can't put an m in my GCF. So notice the only thing that I can take out of this problem is a 1. And that won't help me because watch this. If I were to put a 1 here as my GCF, 1 times the first term would have to get me 9m squared. That's still going to be 9m squared. And 1 times the second term would have to get me -1. That would have to be -1. So notice there's no benefit to rewriting that. We wouldn't do that. If the GCF is 1, then that means that we just can't remove that. So that step I would not take there. So now, doesn't mean we're done. We just can't take out a GCF. This is 2 terms, so that might be a difference of squares. Is it a binomial? Yes. Does it have subtraction? Yes. Are these perfect squares? Yes, because this is 3m times 3m, and this is 1 times 1. So we would use our difference of squares pattern on this one. 3m times 3m to get the 9m squared. 1 times 1 to get the 1, plus and minus, because that's the pattern. And this would be my answer. So if the GCF turns out to be just 1, there's no benefit to that. So you don't have to bother with it. All right, we're going to look at one last example. 4a cubed b minus 8a squared b squared plus 2ab to the third. Now, every problem, you're going to start by checking for a GCF. We have coefficients of 4 and 8 and 2. All those will divide by 2. All the terms have the variable a, so I'm going to find the smallest power of a, which is a to the first, and make that part of my GCF. All of the terms also have b's, so I find the smallest power of b and make that part of my GCF. So 2ab is my greatest common factor. So I will begin factoring with that. So 2ab times your first term has to give you 4a to the third b. So it looks like that'll need to be 2a squared. 2ab times your second term has to give you -8a squared b squared. That will need to be -4ab. And then finally, 2ab times your third term needs to give you 2ab to the third. So it looks like that will be plus b squared. All right, now notice that inside your parentheses you have 3 terms. So that would be a guess and check problem. So my 2a squared, there's only one way to get that, which is 2a times a. And then notice that for my b squared, only one way to get that, b times b. So bring down your GCF, and then get ready to try guess and check. So only one choice over here. I can do 2a times 1a. Notice I do need some negatives here. It would take two negatives to make that positive b squared, so I'm going to put a minus b and a minus b. So here's my guess, and really this is the only guess I've got. So now let's check it. All right, I'm going to leave 2ab alone for the moment and multiply these two binomials together. 2a times 1a is 2a squared. 2a times negative b is negative 2ab. Negative b times a is negative ab. And negative b times negative b is a positive b squared. Combine like terms, it looks like we're going to get 2a squared minus 3ab plus b squared. And then we'll distribute. 2ab times 2a squared is 4, a to the third b. 2ab times negative 3ab is a negative 6, a squared b squared. And then finally, 2ab times b squared is 2ab to the third. That does not check out. That's wrong. We've got the wrong middle term. And the thing is, there's no way to rearrange this and do any better. So what that means is we cannot factor that trinomial. And this would be our final answer. So in every single one of these problems, you need to start by checking for a GCF. If you can take one out, great, then do it. If you can't, that's also okay. But then you need to look to see if you're dealing with two terms or three terms, and at least try. If it's two terms, at least try to do difference of squares. If it's three terms, at least try to do guess and check. Sometimes you'll have to do GCF and one of those, sometimes not. So if you have any questions about what you're doing here on these, then please be sure and let me know.